carbon dioxide gas but silicon dioxide solid substance. Why? This is today's lesson. First of all, let's try to know the positions of the concerned elements in the periodic table. Elements of column 14: carbon, silicon, germanium, tin, lead, fluorovium. Elements of column 15: nitrogen, phosphorus, arsenic, antimony, bismuth, moscovium. Elements of column 16: oxygen, sulfur, selenium, tellurium, polonium, livermorium. Now let's try to know why this question arose. That means carbon dioxide gaseous substance, silicon dioxide solid substance. Actually, both the compounds should be same in physical property. In this way, carbon with oxygen form carbon dioxide and silicon with oxygen form silicon dioxide. We know elements of a particular column are same in physical properties, almost same. So carbon dioxide and silicon dioxide should be same in physical properties. That means if carbon dioxide is gaseous substance, then silicon dioxide should be gaseous substance. But actually carbon dioxide is gaseous substance but silicon dioxide is solid substance. In this lesson we are going to learn the reason behind this. So let's go to the detail. The very first point is states of matters. Let's see molecular positions of solid, liquid and gaseous substances. First of all, solid substance. In this case, suppose this is sodium chloride. Here the particles are sodium and chlorine. The arrangement of these particles are in this way. This is positively charged sodium ion. This is chloride ion. Sodium ion, chloride ion, sodium, chloride, 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 sodium, chloride. Here the particles are very close to each other. That means in this case interparticular attraction force is very high, electrostatic force of attraction, and intermolecular space is very low, but intermolecular attraction is very high. That is why the particles remain close to each other and particles form solid substance. And for this reason, boiling point of sodium chloride is 1465 degree Celsius. This is very high. This is the structure of solid substance. Now let's see structure of liquid substance. For example, water. Structure formula of water is this. electronegativity of oxygen is 3.5, hydrogen is 2.1. So covalently bonded electrons move towards oxygen. That is why oxygen gets negatively charged and hydrogen gets positively charged. Another molecule of water, this is negatively charged, this is positively charged. Negative end of one molecule of water, this is positive end of another molecule of water. An attraction is developed among the water molecules, but this attraction is not as strong as in sodium chloride. That is why boiling point of water is only 100 degrees Celsius temperature, and in liquid substance molecules remain apart from each other. Only weak intermolecular attraction force is there. This is the structure of liquid substance. That means in solid substance particles remain very close to each other, but in liquid substance particles remain apart from each other. Now let's see the structure of gaseous substance. Suppose oxygen, structure formula of oxygen is this, same electronegativity. So this is not polar, this is nonpolar molecule, and as a result there is no oxygen-oxygen attraction. That is why in gaseous substance molecules remains far apart from each other, and boiling point of oxygen is minus 183 degrees Celsius temperature. Now let's see at a glance. In solid substance particles remain very close to each other. In liquid substance particles remain apart from this, and in gaseous substance molecules remain far apart from each other. These are the structures of solid, liquid and gaseous substance. In solid substance intermolecular attraction force is very high, but intermolecular attraction space is less. In liquid substance intermolecular attraction force is less, but intermolecular attraction space is high. In gaseous substance intermolecular attraction force is very less, but intermolecular attraction space is very high. Now let's move on to the next point. Now the point is orbital structure of carbon dioxide. Let's see through electronic configurations of carbon and oxygen. First of all, electronic configuration of carbon is 1s2, 2s2, 2p2. Oxygen 8, 1s2, 2s2, 2p4. Another oxygen 8, 1s2, 2s2, 2p4. Let's write in box system 2s, this is 2px, 2py, 2pz. Here 2 electrons, 1, 2, 3, 4. Carbon in box system, this is oxygen, 2s, 2p, 1, 2, 3, 4. Here 1 electron of 2s orbital jumped to 2pz orbital. This is 2pz, 2px, 2py. Oxygen in box system 2s, 2p, 2 electrons, 1 electron, and here another electron. This is 2s, 2px, 2py, and 2pz. In carbon dioxide, carbon is sp hybridized. Then this is sp orbital, this is another sp orbital, and 2 orbitals remains unhybridized. This is 2py and this is 2pz. But in carbon dioxide, oxygen is sp2 hybridized. sp2, sp2, and this is sp2 orbitals. And 1 orbital remains unhybridized. This sp2 orbital containing 1 electron, this sp orbital containing 1 electron overlap each other, and then carbon oxygen single bond is formed. This sp2 orbital contains 1 pair of electrons. This sp2 orbital contains 1 pair of electrons, and this unhybridized orbital contains 1 electron. This orbital is 2pz orbital. 2py orbital of carbon overlaps with 2pz orbital of oxygen, and then a stable pi bond is formed. Similarly, this oxygen sp2 hybridized and 1 orbital remains unhybridized. This is 2pz, and hybrid orbital overlap and sigma bond is formed. 2pz orbital of oxygen, unhybridized orbital of oxygen 2pz overlaps with the 2pz of carbon. Then a stable pi bond is formed. 2pz, 2pz, 2py, 2pz. So in this way, carbon dioxide is formed. Here, sigma bond is formed by the overlap of sp2 and sp orbital of carbon, sp2 orbital of oxygen. Here, sp orbital of carbon, sp orbital of oxygen, and pi bond is formed. 2pz orbital with 2pz orbital of carbon. Another pi bond is formed. 2py orbital of carbon with 2pz orbital of oxygen. Here, since the principal quantum numbers are same, that is why a stable pi bond is formed. It's possible here because of the same principal quantum number. This is all about orbital structure of carbon dioxide. Let's see the state of carbon dioxide now. Now the point is states of carbon dioxide. Let's see the matter. Structure formula of carbon dioxide is this. Electronegativity of oxygen is 3.5, carbon is 2.5, this oxygen 3.5. As electronegativity of oxygen is higher than carbon, that is why this carbon oxygen bond becomes polarized. Similarly, this oxygen carbon bond becomes polarized. But polarity of this bond cancels polarity of this bond. That is why the dipole moment of this molecule is 0 dBi. Ultimately, this molecule becomes nonpolar molecule. So this is nonpolar molecule. As it is nonpolar molecule, that is why no attraction is developed among the carbon dioxide molecules. That is why carbon dioxide molecules remain apart from each other. That means the state of carbon dioxide is gaseous. That is, carbon dioxide is a kind of gaseous substance, as there is no polarity in carbon dioxide molecule. Let's see the next point. Now the point is states of silicon dioxide. Let's see the physical state of silicon dioxide. Here, the bonds in silicon dioxide are oxygen, silicon, oxygen. There is no double bond is in silicon dioxide. That is why this oxygen again bonds to silicon. Again bonds to silicon. In this way it proceeds. This silicon again bonds to another oxygen. This is silicon again, oxygen, silicon. Here silicon. Here oxygen, oxygen, silicon, silicon, oxygen, silicon. Here oxygen again. Here oxygen, here oxygen, oxygen, oxygen. Here oxygen, here oxygen. That means a macromolecule of silicon dioxide is formed through polymerization. A giant molecule of silicon dioxide is formed in which oxygen is common to two silicon dioxide tetrahedra. Here silicon dioxide shape is tetrahedral and oxygen is common to two silicon dioxide tetrahedra. In this case, we see that oxygen cannot form pi bond with silicon. This is the main reason to be solid substance. Through polymerization, silicon dioxide remains as crystalline solid substance, as a giant molecule, a big network structure. The reason behind this is oxygen here cannot form stable pi bond with silicon. That is why this oxygen bonds to another silicon, and in this way silicon dioxide forms polymer molecule, a macromolecule, and remains as solid substance. Now we should know what is the reason behind not forming a stable pi bond between silicon and oxygen. Let's see the matter. Now the point is reason behind giant structure, and the reason is no stable pi bond between silicon and oxygen. That is why oxygen bonds to another silicon of another molecule. Let's see the reason of not forming a stable pi bond. It is found through electronic configuration of silicon and oxygen. Now let's see electronic configurations of silicon and oxygen. Silicon 14, 1s2, 2s2, 2p6, 3s2, 3p2. Oxygen is 8, 1s2, 2s2, 2p4. In box system we can write for silicon this is 3s and this is 3p. 1 electron, 1 electron, 1 electron, 1 electron at the excited state, silicon excited state. Oxygen box system 2s, 2p. Here 2 electrons, 2 electrons, 1 electron, 1 electron. This is oxygen. Silicon undergoes sp hybridization. Now let's see. Silicon sp orbital, sp orbital. This is unhybridized 3py, this is 3pz. So this is 3py orbital and another orbital, this is 3pz orbital, and oxygen undergoes sp2 hybridization. So oxygen sp2 hybridization, one orbital remains unhybridized. This oxygen sp2 hybridization, one orbital remains unhybridized. This is 2pz, but this is 3py and 3pz. Here head-to-head overlap happens, so this bond is formed, silicon oxygen sigma bond. Here head-to-head overlap, silicon oxygen sigma bond is formed. But to form pi bond, this is 2pz orbital of oxygen. To form pi bond between silicon and oxygen, 3py orbital needs to overlap with 2pz orbital. 3py, 2pz. Here, to form another pi bond, this 2pz orbital needs to overlap with 3pz orbital. 2pz orbital, 3pz orbital. Because of the difference in principal quantum number, 3py, 2pz. Here 2pz, 3py. There is a difference in principal quantum number. That is why no stable pi bond is formed, because of the difference in principal quantum number. That is why this oxygen forms another sigma bond with silicon. Again oxygen, again silicon. So this is the only reason of not forming stable pi bond between silicon and oxygen. Here principal quantum numbers are different, 3py, 2pz. That is why stable pi bond is not formed. This is the main reason of forming giant molecule, a macromolecule. That is why silicon dioxide remains as solid substance, but carbon dioxide, no polarity, remains as gaseous substance. Now today, thank you very much.